This is a walkthrough of the Kubermatic Developer Platform, KDP, driven end-to-end by an AI agent. In this run, the agent has two things: a bare Kubernetes MCP server, so it can shell out to kubectl, and a KDP skill. A skill is just a markdown file that teaches the agent how KDP is structured, what workspaces are, how service bindings work, what permission claims it needs to set. No custom server, no API integration. Just instructions the agent reads at startup. The first prompt is straightforward. Which services and databases are available? The skill loads, and the agent goes to kubectl get API exports. In KCP, API exports are how services advertise themselves to the platform. Listing them is how you discover the catalog. Two database types, PostgreSQL and MongoDB, plus AWS, PKI for certificates, source code management, an app engine, web app hosting, and KKP for provisioning Kubernetes clusters. None of them are bound to this workspace yet, so the agent offers to enable one. Instead, we give it the full scenario. Create a workspace for a customer called Customer X. Inside it, a production project. In that project, provision a Postgres database, an SSL certificate, and an app engine deployment, with the Postgres credentials mounted into the app as environment variables. And do it end-to-end, without handholding. The agent breaks this into a to-do list: organization workspace, production project, 3 service bindings, then the 3 resources with credentials wired through. It creates Customer X as a KDP-organization workspace, switches into it, and creates the production project as a KDP-project. 2 kubectl applies, 2 workspace navigations. We're in the right context. This is the part that matters. The agent applies 3 API bindings in a single call for the database service, PKI, and app engine. Each binding includes explicit permission claims, secrets, namespaces, events. Without those claims, the platform has no authority to write database credentials into your workspace. The Postgres service would create the secret, but it would never land where your app can see it. The skill documents this requirement, so the agent gets it right on the first try. With the services bound, it uses explain resource to learn the shape of a Postgres instance, a certificate, and an app. Then it provisions the Postgres with 20 gigs of storage and the certificate with a CN of customer-x.production.example.corp, both in parallel. The connection details will land in secrets named production-db-credentials and production-tls-credentials. The agent waits for the database to become ready, reads back the production-db-credentials secret, and decodes the base 64 values. Then it applies the app resource, 2 replicas, 500 millicores, 512 megabytes, with db host, db port, db name, db user, db password, and db SSL mode all injected from the decoded secret. Setup complete. Organization created, project created, database ready, certificate ready, app deployment syncing from source. The agent even flags one honest action item. The Git source URL is a placeholder and would need to point at a real repo before the build succeeds. About 4 minutes of agent work for something that at most companies still takes a ticket, a meeting, and at least one DM in Slack. Now, verify this from the human side. Opening the KDP dashboard, Customer X is there as an organization. Inside the production project, all 3 services are marked as added. The Postgres instance shows its 20 gig storage configured. On the app resource, the envars are filled in. DB host pointing at the real database endpoint, DB port at 5432, the rest of the connection details wired through. Same platform, 2 different interfaces. Nothing special happens because the request came from an agent. It went through the same API, the same RBAC, the same everything a human clicking buttons would hit. Final prompt. Please delete the Customer X workspace. The agent confirms the destructive action, navigates back to root, and deletes. Refreshing the dashboard, Customer X is gone. Only the demo organization remains. One markdown file, plain kubectl, and a real end-to-end provisioning flow. That's the core claim of an API-first platform. Once the surface is consistent, an AI agent with a light nudge about conventions can operate it as well as a human.